What if I told you that right now, at this very moment, something is passing through our solar system that could fundamentally change everything we thought we knew about the universe? And I'm not talking about some distant scientific theory or mathematical abstraction. I'm talking about an object that exists, that astronomers are tracking, and that has properties so bizarre that scientists are having emergency meetings about what it might mean. In June 2025, astronomers detected something entering our solar system. They named it Comet 3I Atlas. The 3I designation means it's only the third confirmed interstellar object, something that originated outside our solar system, that we've ever detected passing through. But here's where it gets absolutely insane. This thing shouldn't exist according to our current understanding of physics. And what it's brought with it might be evidence of something so profound that it could rewrite our understanding of reality itself. Dr. Michelle Bannister from the University of Canterbury, one of the lead astronomers tracking this object, said something in a recent interview that sent chills down my spine. She said, and I quote, "We've never seen spectroscopic signatures like this. If these readings are correct, we're looking at matter that has no business existing in our universe." Let that sink in for a second. Matter that has no business existing in our universe. Not we don't understand it yet, not it's unusual, but matter that fundamentally violates the rules we thought governed reality. By the end of this deep dive, you're going to understand exactly why this single object passing through our solar system has the in the end potential to be the most significant discovery in human history. And I promise you, what you learn today will change the way you see everything around you. Before we dive into the mind-bending details, do me a huge favor, smash that like button and subscribe to the channel. This is the kind of content that takes weeks of research to put together, and your support makes it possible. Also, drop a comment telling me what country you're watching from and what time it is for you right now. I love seeing our global community come together for these deep dives. Now, let's get into something truly extraordinary. So, let's start with the basics, because you need to understand what makes 3I Atlas so different from anything we've encountered before. To appreciate this, we need to talk about interstellar objects in general. Think of our solar system like a pond. We're sitting in this pond with our sun and planets, and everything in our pond has been here for about 4.6 billion years, swirling around in predictable patterns. Now, occasionally, something from another pond, another star system passes through ours. These are interstellar objects, and they're incredibly rare to detect. Why? Because space is unimaginably vast, and these objects are moving at incredible speeds. The first confirmed interstellar object we detected was Oumuamua in October 2017. Hawaiian. Astronomers spotted it using the Pan-STARRS telescope, and the name means scout or messenger in Hawaiian. Oumuamua was weird from the start. It was cigar-shaped, tumbling end over end, and it accelerated as it left our solar system in a way that couldn't be explained by the sun's gravity alone. Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University, famously suggested it might be an alien probe. While most scientists disagreed with that specific interpretation, everyone agreed on one thing. Oumuamua was unlike anything we'd seen. Then came 2I Borisov in August 2019. This was more comforting to astronomers because it behaved like a comet. It had a tail. It outgassed as it approached the sun, and its chemistry seemed to match what we'd expect from comets formed around other stars. Dr. Piotr Gozik from Jagiellonian University led research showing that Borisov's composition suggested it came from a solar system very different from ours, possibly one with a more active early history. But 3I Atlas? This is where everything we learned gets thrown out the window. First detected in June 2025 by the Asteroid Terrestrial Impact Last Alert System. That's what a TLAS stands for. This object immediately stood out. Its trajectory showed it was definitely interstellar, coming from the direction of the constellation Lyra at approximately 97 kilometers per second relative to the Sun. But that's not the shocking part. When astronomers turned their spectroscopes toward it, instruments that analyze the light an object reflects or emits to determine its composition, they saw something impossible. The spectroscopic signature showed elements that shouldn't be together. It's like looking at water and finding that it's somehow made of helium and iron at the same time. It violates what we know about chemistry. Dr. Bannister's team, working with data from the European Southern Observatory's Very Large Telescope in Chile, documented absorption lines in the spectrum that don't match any known mineral or chemical compound in our comprehensive databases. And we have very comprehensive databases. We know what every element looks like when light passes through it. We know what happens when elements combine. This matched none of it. Here's an analogy to help this land. Imagine you've been a chef your entire life. You know every ingredient, every spice, every possible combination of flavors. You can taste something blindfolded and tell exactly what's in it. Then someone hands you a dish, and when you taste it, the flavor is completely unknown. It's not that it's a new combination. The actual taste itself represents something that shouldn't exist in cooking. That's what astronomers are experiencing with 3I Atlas. But it gets stranger. The object's albedo, how much light it reflects, is wrong. It's too bright for its size and composition. It's reflecting more light than it should be able to, almost as if the surface is somehow amplifying photons. That shouldn't be possible with natural materials. And here's something that kept astronomers up at night. The object is cold, way too cold, even accounting for its distance from the Sun. Its thermal signature shows it's radiating heat at a temperature that suggests it's colder than the cosmic microwave background. Radiation, the afterglow of the Big Bang that permeates all of space. Let me say that again. This object appears to be colder than the coldest thing that can naturally exist in the universe. That should be impossible. It's like finding an ice cube that's colder than the freezer it's sitting in. The universe has a minimum temperature, called absolute zero, which is approximately 2.7 Kelvin thanks to the cosmic microwave background. Nothing can be colder than the environment around it without active cooling. Yet 3I Atlas seems to be. Now, before we go further, let me address what you're thinking. Could this be an error? Could the instruments be wrong? That's what scientists thought at first. But here's the thing. This has been confirmed by multiple independent observatories using different instruments and different methodologies. The James Webb Space Telescope confirmed it. The Hubble Space Telescope confirmed it. Ground-based observatories around the world confirmed it. The data is solid. So, what are we looking at? To understand the leading theories, we need to understand something called exotic matter. And this is where your mind is about to be blown for the first time today. In physics, when we talk about exotic matter, we're not talking about some rare element from another planet. We're talking about matter that has properties fundamentally different from the matter that makes up everything you've ever touched, seen, or experienced. And yes, this is real science, not science fiction. Normal matter, the stuff that makes up you, me, planets, stars, everything is made of atoms, which are made of protons, neutrons, and electrons. These particles have positive mass, meaning they respond to gravity in the way you'd expect. They're attracted to other massive objects. Drop a ball, it falls down. That's positive mass. But in 1948, a physicist named Hermann Bondi proposed a thought experiment. What if matter could have negative mass? Not antimatter, which is different negative mass. This would mean matter that, instead of being attracted by gravity, would be repelled by it. If you dropped a ball with negative mass, it would fall up. This sounds absurd, but here's where it gets interesting. Einstein's equations of general relativity don't forbid negative mass. In fact, certain solutions to Einstein's field equations require it. Dr. Miguel Alcubierre's famous warp drive, Equations from 1994 showed that faster-than-light travel might be possible if you had access to matter with negative mass. You could create a bubble of spacetime that moves faster than light, while nothing inside the bubble violates the speed of light limit. For decades, this was purely theoretical. No one had ever observed negative mass matter in nature. It was considered possible mathematically, but probably not real physically. Until 2017, when researchers at Washington State University, led by Dr. Peter Engels, created a fluid with negative mass in the laboratory. They cooled rubidium atoms to just above absolute zero and used lasers to manipulate them into a state where they exhibited negative effective mass. When they pushed on this fluid, instead of accelerating in the direction of the push, it accelerated in the opposite direction. Mind-blowing, right? They essentially created matter that moves backward when you push it forward. But that was in a highly controlled laboratory setting, using quantum effects and near absolute zero temperatures. No one expected to find anything like this occurring naturally in space, and certainly not on the scale of an entire comet-sized object. Yet here's what has scientists in a frenzy. Some of the anomalous properties of 3I Atlas could be explained if portions of it are composed of matter with negative or exotic mass properties. The excessive brightness? If the object contains regions of negative mass, it could create gravitational lensing effects around itself, bending light in unusual ways and making it appear brighter than it should. Think of it like a magnifying glass effect, but created by weird gravity instead of curved glass. The impossible coldness? Matter with negative mass would interact with thermal radiation differently than normal matter. It could potentially repel heat in the same way it repels gravity, creating a region around it that's colder than the ambient environment. The spectroscopic signatures that don't match known compounds? If you're looking at matter that's partially composed of exotic mass states, its interaction with light would be completely different from normal matter. The absorption lines wouldn't match anything in our databases because we've only ever cataloged normal matter. Now, I know what you're thinking. If this object has exotic matter, where did it come from? And that question leads us down a rabbit hole that will fundamentally change how you understand the universe. Dr. Catherine Fries from the University of Texas at Austin, one of the world's leading experts on dark matter and exotic physics, published a preliminary paper in September 2025 suggesting the 3I Atlas might have originated not from another star system, like we initially thought, but from an even stranger place, the cosmic dark matter web. Here's what that means. Between galaxies, there's a vast network of dark matter filaments that connect galaxy clusters like a cosmic spider web. We can't see dark matter directly. It doesn't interact with light, but we can infer its existence from its gravitational effects. This dark matter web contains about 85% of all the matter in the universe. What if, Fries proposes, in some regions of this dark matter web, conditions exist that can create exotic matter objects? These would be objects formed not in the hot, dense environments of star-forming regions, but in the cold, diffuse medium between galaxies where dark matter dominates. If this is true, then 3I Atlas isn't just a comet from another star. It's a visitor from the space between stars, a realm we've never sampled before, carrying with it matter in states we've never encountered. It would be like a message in a bottle from a completely unknown ocean. But here's where this gets even more mind-bending, and this is going to be the second major revelation today. If exotic matter can exist naturally in the universe, then nearly everything we thought we understood about cosmology might need to be revisited. You see, cosmologists have been puzzled for decades about dark energy, the mysterious force causing the universe's expansion to accelerate. We don't know what dark energy is. We've just given it a name because we can measure its effects. But what if dark energy isn't a mysterious force at all? What if it's actually the effect of exotic matter with negative mass spread throughout space? In 2018, Dr. Jamie Farnes from the University of Oxford published a paper proposing exactly this. A dark fluid theory, suggesting that dark matter and dark energy might both be manifestations of negative mass matter filling space. When you run the simulations with this model, it produces cosmic structures that match what we observe. Galaxies form where they should. The cosmic microwave background looks right. The acceleration of the universe's expansion matches the data. And now we potentially have a sample of this exotic matter passing through our solar system. This is why scientists are having emergency meetings. This is why there are rumors of classified briefings being given to government agencies. Because if we can study 3I Atlas closely enough before it leaves our solar system, we might be able to answer some of the deepest questions in physics. We might finally understand what dark matter and dark energy actually are. We might verify whether exotic matter exists in nature. We might discover that the universe is far stranger and more wonderful than we ever imagined. But there's a problem. And this is where things get urgent. 3I Atlas is moving fast, really fast. At 97 kilometers per second, it's hauling through our solar system at speeds that make our fastest spacecraft look like they're standing still. And here's the critical thing. We have a window. A very narrow window to study it before it disappears back into interstellar space, possibly forever. The object was closest to the Sun, its perihelion, in September 2025. That's when it was brightest and easiest to study. But by the time most of the scientific community mobilized resources to observe it, valuable time had already passed. As I'm speaking to you now, in November 2025, it's already moving outward, heading back toward interstellar space. We're in a race against time. Every day that passes, the object gets fainter, harder to observe, and more difficult to analyze. Within a few months, it'll be too far away for even our most powerful telescopes to gather useful data. And then it's gone. Possibly the most important scientific sample we've ever had access to, and it's slipping through our fingers. This is why there's been an unprecedented mobilization of astronomical resources. The James Webb Space Telescope has devoted significant observation time to tracking 3I Atlas. Multiple ground-based observatories have coordinated their efforts. There's even been serious discussion, and this has not been made public yet, but sources within NASA confirm it about whether it's possible to launch a rapid mission to intercept the object. Dr. Alan Stern, the principal investigator of the New Horizons mission that visited Pluto, has been consulting with engineers about whether a fast-track mission is feasible. The problem is time and speed. Even if we launched something today using our fastest rockets, by the time it caught up to 3I Atlas, the object would be so far from the Sun that solar panels wouldn't work, and the spacecraft would be operating in near total darkness. But here's what really gets me excited. What if we don't need to send a spacecraft? What if we've been thinking about this all wrong? In early October 2025, a team led by Dr. Abraham Loeb, yes, the same Loeb who proposed Oumuamua, might be artificial, suggested something radical. Instead of trying to catch up to 3I Atlas, what if we could use gravitational lensing to study it in unprecedented detail? Here's the idea. The Sun's gravity bends light around it, creating what's called a gravitational lens. At a distance of about 550 astronomical units from the Sun, 550 times the distance from Earth to the Sun, there's a point called the solar gravitational lens focal line. If you could place a telescope there, you could use the Sun's gravity as a giant magnifying lens to observe distant objects with incredible resolution. Loeb's proposal is this. We already have spacecraft heading in that direction. Voyager 1 and Voyager 2 are out there, though not positioned perfectly. But what if we launched a new mission, not to catch 3I Atlas, but to reach this gravitational lens focal point? From there, we could observe not just 3I Atlas, but other interstellar objects with resolution that would allow us to see surface features, composition details, and properties that are impossible to observe any other way. The technology exists. The physics works. The only question is whether we have the will and the resources to do it. But here's the beautiful thing. Studying 3I Atlas has created enough scientific interest and public awareness that this kind of ambitious mission suddenly seems possible. And this brings me to something crucial that I want you to understand about the nature of scientific discovery. We tend to think of science as this steady, linear progression where we gradually learn more and more. But that's not how it actually works. Science progresses in leaps. There are long periods of incremental advances, and then suddenly, something appears that forces us to rethink everything. Paradigm shifts, Thomas Kuhn called them. The discovery of cosmic microwave background radiation in 1964 by Arno Penzias and Robert Wilson was one of those moments. They were trying to eliminate noise from a radio antenna, and they discovered the afterglow of the Big Bang. That single observation transformed cosmology overnight. The detection of gravitational waves in 2015 by the LIGO collaboration was another. A century after Einstein predicted them, we finally detected ripples in space-time itself, opening an entirely new way of observing the universe. 3I Atlas has the potential to be one of those moments. And here's what makes this particularly special. Unlike most major scientific discoveries that happen in laboratories or through complex experiments that the public never sees, this is happening in real time in the sky where anyone with a good enough telescope can observe it. This is a public discovery. We're all witnesses to potentially one of the most important moments in human scientific history. But to really appreciate what's at stake here, we need to talk about what finding exotic matter would actually mean for physics. And this is where things get truly mind-bending. This is your third mind-blown moment of this deep dive. Let me paint you a picture of what the universe looks like if exotic matter is real and abundant. First, faster-than-light travel stops being science fiction. I'm not exaggerating. The biggest obstacle to interstellar travel has always been the speed of light limit. Einstein's special relativity tells us that nothing can accelerate to or pass the speed of light because it would require infinite energy. But that's for normal matter traveling through space. The Alcubierre warp drive I mentioned it earlier works by contracting space in front of a spacecraft and expanding it behind, creating a wave of spacetime that carries the ship faster than light without the ship itself ever exceeding light speed within its local bubble. The catch? It requires exotic matter with negative energy density to stabilize the warp bubble. For decades, this was purely theoretical because we assumed exotic matter didn't exist in nature. But if 3I Atlas is composed partially of exotic matter, it means nature has figured out how to create this stuff. And if nature can do it, there's no physical law preventing us from figuring out how to create or harvest it ourselves. Dr. Harold Sonny White, formerly of NASA's Advanced Propulsion Physics Laboratory, has been working on warp drive concepts for years. In a paper published in 2021, he showed that the amount of exotic matter needed for a warp drive might be much less than previously thought, potentially only a few tons instead of the mass of a planet. If we could analyze 3I Atlas and understand how its exotic matter is structured, we'd have a blueprint for creating warp-capable spacecraft. Think about what that means. The nearest star system, Alpha Centauri, is 4.37 light-years away. With conventional propulsion, it would take tens of thousands of years to reach. With a warp drive, potentially weeks or months. The entire galaxy becomes accessible within a human lifetime. But faster-than-light travel is just the beginning. Exotic matter would revolutionize energy generation. One theoretical application involves creating what's called a Casimir drive propulsion system that extracts energy from the quantum vacuum itself. The vacuum of space isn't actually empty. It's seething with quantum fluctuations, virtual particles popping in and out of existence. With exotic matter, you could potentially tap into this zero-point energy. If that sounds too good to be true, consider this. The Casimir effect, predicted by Dutch physicist Hendrik Casimir in 1948, has been experimentally verified. When you place two uncharged metal plates very close together in a vacuum, they experience an attractive force caused by quantum fluctuations. This is vacuum energy being converted into mechanical work. It's real, it's measurable, and with exotic matter to amplify and harness it, you could have essentially unlimited energy. Imagine a world where energy is no longer scarce. No more fossil fuels. No more nuclear waste. Spacecraft that never run out of power. That alone would transform human civilization beyond recognition. But here's where it gets even stranger, and this is going to challenge everything you think you know about causality and time. Exotic matter with negative energy density doesn't just enable faster than light travel, it might enable time travel. In 1988, physicist Kip Thorne and his colleagues published a paper showing that traversable wormholes shortcuts through space-time connecting distant points could theoretically be stabilized using exotic matter. Without exotic matter, wormholes collapse too quickly for anything to pass through them. But with exotic matter propping them open, you could create a tunnel through space-time. Now, here's the mind-bending part. If you took one end of a wormhole and accelerated it to near light speed while leaving the other end stationary, time dilation effects would cause the two ends to age at different rates. This creates what's called a closed time-like curve, a path through space-time that loops back on itself. You could potentially travel through the wormhole and arrive at a time earlier than when you left. This is real physics, published in peer-reviewed journals. The only reason we don't have time machines is that we've never had access to exotic matter to build one. But if 3i Atlas proves that exotic matter exists in nature, now I know some of you are thinking about paradoxes. What happens if you go back in time and prevent your own birth? This is where physics gets really interesting. There are several proposed solutions. The Novikov self-consistency principle suggests that the universe is deterministic in a way that prevents paradox. You can travel back in time, but you can't change the past because whatever you do in the past already happened. It's a stable time loop. Alternatively, the many worlds interpretation of quantum mechanics suggests that when you change the past, you create a branching timeline. You don't erase your own timeline. You create a new one, where things happen differently. Which interpretation is correct? We don't know. But here's what's absolutely fascinating. If exotic matter exists, and we can build the technology to test these theories, we'll find out. The universe will show us how it handles causality. This is why 3i Atlas is so much more than just a comet. It's a potential key to understanding the deepest mysteries of physics. It's a gateway to technologies that would make us a truly spacefaring civilization. It's evidence that the universe is far more strange and wonderful than we imagined. But there's something else about 3i Atlas that we need to talk about. Something that has implications beyond just physics and technology. Something that touches on perhaps the most profound question humans have ever asked. Are we alone in the universe? Here's what I'm about to tell you might sound like science fiction, but I want you to understand that this is being seriously discussed by serious scientists right now. If exotic matter exists naturally in the universe, and if it's found in the dark matter web between galaxies, then the universe might be far more habitable than we thought. Not just planets around stars, but potentially structures, even civilizations, existing in the vast spaces between solar systems, built from or around exotic matter. Dr. Milan Hrkovic from the Astronomical Observatory of Belgrade has published papers on what he calls post-biological civilization scenarios. His argument goes like this. Any sufficiently advanced civilization would eventually move away from dependence on planets and stars. Planets are resource limited. Stars eventually die. But the intergalactic medium, the space between galaxies filled with dark matter, is vast, diffuse, and potentially eternal. If you had access to exotic matter, You could build structures that harness zero-point energy from the quantum vacuum. You wouldn't need a star. You could exist in the cold, dark regions of space, sustained by physics we're only beginning to understand. These civilizations would be effectively invisible to us because they wouldn't emit heat signatures or electromagnetic radiation the way star-based civilizations do. Now, here's where it gets really interesting. What if 3I Atlas isn't just a natural object? What if it's been engineered? Before you dismiss this, remember Oumuamua. Dr. Avi Loeb's suggestion that it might be artificial was controversial, but his reasoning was sound. The object accelerated as it left our solar system in a way that couldn't be explained by normal cometary outgassing or gravitational effects. It was as if something was pushing it. 3I Atlas shows even stranger properties. The impossible spectroscopic signatures, the excessive brightness, the anomalous coldness. What if these aren't just natural phenomena? What if they're the signatures of technology we don't understand, built from materials we've never encountered? I want to be clear. There's no definitive evidence that 3I Atlas is artificial. But there's also no definitive evidence that it's natural. The properties we're observing don't fit neatly into either category. It's genuinely anomalous. The Search for Extraterrestrial Intelligence Institute, SETI, has been monitoring 3I Atlas for electromagnetic signals since August 2025. So far, they haven't detected anything that looks like a deliberate transmission. But that doesn't mean much. If you're a civilization capable of creating or manipulating exotic matter, your technology would be so advanced that we might not even recognize a signal if we saw one. It would be like showing a smartphone to someone from the Middle Ages. They might recognize it as an object, but they would have no framework for understanding what it does or how it works. The signals might be there, encoded in ways we can't detect with our current instruments. But here's what really keeps me up at night. If 3I Atlas is artificial, if it's some kind of probe or artifact from an advanced civilization, then why is it here? Why did it pass through our solar system at this particular time? One possibility is pure coincidence. Space is vast, and trajectories are random. Maybe we just happen to be in the right place at the right time to observe it. But another possibility is that it's not a coincidence at all. What if interstellar objects like this are common, but we've only recently developed the technology to detect them? The Atlas survey that discovered 3I Atlas only became fully operational in 2015. Before that, we had much more limited sky coverage. Oumuamua was detected in 2017, Borisov in 2019, and now 3I Atlas in 2025. That's 3 confirmed interstellar objects in 8 years. Dr. Greg Laughlin from Yale University ran simulations in 2018, suggesting that there might be thousands of interstellar objects passing through the inner solar system every year. We're just not seeing them because they're faint, fast-moving, and we're not looking in the right places at the right times. If that's true, then the galaxy might be teeming with these objects. Some natural, formed in the dark matter web, or ejected from other solar systems. Some possibly artificial, relics, or probes from civilizations we haven't encountered. The space between stars might not be an empty void, but a busy highway of objects carrying matter, information, and perhaps even life between star systems. This is called panspermia, the idea that life might be distributed throughout the galaxy by natural processes. If exotic matter can exist in the cold of interstellar space, could it provide an environment for exotic forms of life? Not life as we know it, based on carbon chemistry and liquid water, but something completely different, based on physics we're only beginning to understand? These are no longer fringe ideas. These are questions being seriously considered by mainstream scientists because 3I Atlas has forced us to expand our conception of what's possible. And this brings me to the fourth major mind-blown moment. If we're seeing more interstellar objects now because our detection capabilities have improved, And if some significant fraction of these objects have exotic properties, then we need to fundamentally rethink our models of the universe. Let me take you through what cosmologists call the cosmic inventory problem. We've been trying to account for everything in the universe, all the matter, all the energy, and the numbers don't add up. Normal matter, the stuff made of atoms that we can see and touch, makes up only about 5% of the universe's total mass energy. About 27% is dark matter, which we can detect through its gravitational effects, but have never directly observed. And a whopping 68% is dark energy, the mysterious force accelerating the universe's expansion. Here's the embarrassing truth. We don't know what 95% of the universe is made of. We've given it names dark matter and dark energy, but those are just placeholders for our ignorance. It's like a budget where 95% of your expenses are listed as miscellaneous. That's not a budget. That's a confession that you don't know where your money is going. But what if we've been categorizing things wrong? What if what we call dark matter and dark energy are actually manifestations of exotic matter states that we're only now beginning to detect? This is where Dr. Jamie Farn's dark fluid theory becomes really compelling. If exotic matter with negative mass exists throughout space, it would create gravitational effects that look exactly like what we attribute to dark matter. It would push galaxies apart, which looks exactly like what we attribute to dark energy. One substance with exotic properties, potentially explaining both mysteries. And here's the beautiful thing. This theory makes testable predictions. If dark matter is actually exotic matter, then we should occasionally observe clumps of it, like 3I Atlas, passing through our solar system. The frequency of these observations should match the predicted density of exotic matter needed to explain cosmological observations. We've now detected 3 interstellar objects in 8 years. 2 of them, Oumuamua and 3I Atlas, show anomalous properties. That's a 67% hit rate for weirdness. If we keep observing at this rate and keep finding strange objects, it becomes harder and harder to dismiss this as coincidence. But let's zoom out even further. If exotic matter is common in the universe, what does that tell us about the nature of reality itself? In quantum field theory, the framework that describes how fundamental particles interact, the vacuum of space isn't empty. It's a seething foam of quantum fluctuations, where virtual particles constantly pop in and out of existence. These fluctuations have energy, called vacuum energy or zero-point energy. When physicists calculate how much energy should be in the quantum vacuum based on our theories, they get a number that's outrageously large, about 10,120 times larger than the observed energy density of the universe. This is called the cosmological constant problem, and it's one of the biggest unsolved problems in physics. The universe should be drowning in vacuum energy, but it's not. Why not? Nobody knows. It's as if something is canceling out most of the vacuum energy, leaving just a tiny residue that we observe as dark energy. What if exotic matter is that something? What if the universe is filled with regions of negative and positive energy density that mostly cancel out, leaving only the small imbalance we observe? If this is true, and I want to emphasize this is still speculative, but increasingly plausible, then the fundamental structure of reality is very different from what we thought. Space isn't a passive stage where matter and energy perform. Space itself is an active participant, full of exotic states that shape the evolution and structure of everything. This has philosophical implications that are hard to overstate. It means the universe is fundamentally stranger than the materialist paradigm that's dominated science for centuries. It suggests there are aspects of reality that we've been completely blind to, not because we weren't looking hard enough, but because we didn't have the conceptual framework to even imagine what we should look for. And this is what makes 3I Atlas so significant. It's not just an object. It's a crack in our understanding, a glimpse of something beyond our current paradigm. It's forcing us to ask bigger questions and imagine stranger possibilities. But here's what I want you to understand. This isn't just an abstract intellectual exercise. The questions we're asking about exotic matter, about the nature of space and time, about the possibility of life in forms we haven't imagined. These questions have direct implications for humanity's future. So let's get personal for a moment. How does all of this interstellar objects, exotic matter, the nature of reality, actually affect you? Why should you care about something that's currently millions of kilometers away and moving farther every day? The answer is that we're living through a pivotal moment in human history, and most people don't even realize it. Think about the time scale we're working with here. Modern humans have existed for about 300,000 years. For most of that time, we've been stuck on one planet, looking up at the stars and wondering. It's only in the last century that we've developed the technology to seriously study the universe. And it's only in the last few decades that we've had the capability to detect objects like 3I Atlas. This is your generation's moon landing moment. This is your generation's discovery of the cosmic microwave background. You are alive at the exact moment when humanity might be confirming that there's far more to the universe than we ever imagined. And unlike previous scientific revolutions that took decades to filter down into public consciousness, this is happening in real time. In the age of the internet, where information spreads instantly, you can go online right now and look at the same data astronomers are analyzing. You can read the papers as they're published. You can participate in the discussion about what this means. That's unprecedented. For all of human history, major scientific discoveries were the province of small groups of experts who communicated through journals and conferences that the general public never saw. By the time revolutionary ideas made it into textbooks and public consciousness, decades had passed. But not anymore. You're witnessing this unfold live. And here's why that matters. The decisions we make now about how to study these objects, how much resource to devote to understanding them, what kinds of missions to launch these decisions will be made by governments and space agencies, but they're influenced by public interest and support. When people care about space exploration, when they're excited about cosmic mysteries, funding materializes. Missions get approved. Technology gets developed. The opposite is also true. When public interest wanes, space programs stagnate. We become focused on short-term problems and lose sight of the bigger picture. So your engagement with these ideas matters. The fact that you're here, watching this video, learning about 3I Atlas, asking questions, that's part of a larger cultural shift toward seeing ourselves as a spacefaring species with a destiny beyond Earth. But there's something even more profound I want you to consider. Understanding exotic matter and the true nature of space and time might be the key to solving some of humanity's most pressing challenges. Think about energy. Right now, human civilization is powered primarily by burning things coal, oil, natural gas. We're literally setting ancient organic matter on fire to generate energy. It's primitive when you really think about it. We have nuclear power, which is better, but it produces waste that remains dangerous for thousands of years. Solar and wind are clean, but dependent on weather and location. Now imagine if we could tap into zero-point energy from the quantum vacuum, the energy inherent in empty space itself. If exotic matter is the key to accessing that energy, then 3I Atlas might be showing us the path to unlimited, clean power. No more energy scarcity. No more geopolitical conflicts over oil. No more choosing between economic development and environmental protection, because you'd have both. Climate change? Suddenly solvable. You could power carbon capture technology on a massive scale. You could desalinate seawater for agriculture. You could terraform deserts into forests. All the solutions we currently consider too energy-intensive become feasible, but it goes deeper than practical applications. This discovery challenges something fundamental about how we see ourselves in the universe. For the past few centuries, The dominant scientific narrative has been what you might call the cosmic insignificance story. We learned we're not at the center of the solar system. Copernicus showed us that. We learned our sun is just one of billions in our galaxy. Harlow Shapley showed us that. We learned our galaxy is just one of trillions in the observable universe. Edwin Hubble showed us that. Each discovery made us seem smaller and less significant. This narrative has had psychological effects. There's even a term for it, cosmic nihilism, the feeling that if we're just accidents in a vast, uncaring universe, then nothing really matters. Why care about anything when we're just specks of dust on a slightly larger speck of dust orbiting an ordinary star in an ordinary galaxy? But here's what the 3I Atlas discovery suggests. The universe might be far stranger and more interesting than the cosmic insignificance narrative allows for. If exotic matter exists, if the space between stars is full of structures and possibly life forms we haven't imagined, if the physical laws permit things like faster-than-light travel and time manipulation, then the universe isn't a cold, dead expanse with occasional islands of warmth and life. It's a place teeming with possibilities, most of which we haven't even begun to explore. And here's your fifth mind-blown moment. What if consciousness itself is connected to these exotic properties of spacetime? Stay with me here, because this is where cutting-edge physics meets cutting-edge neuroscience in ways that will sound bizarre, but are being seriously investigated. Dr. Roger Penrose, the Nobel Prize-winning physicist, and Dr. Stuart Hameroff, an anesthesiologist, have proposed a theory called Orchestrated Objective Reduction, OR for short. Their idea is that consciousness arises from quantum processes occurring in microtubules, tiny structures inside neurons. Most neuroscientists have been skeptical of this theory because quantum effects require extremely low temperatures and isolated environments to persist. The warm, wet environment of a brain should cause quantum coherence to collapse almost instantly. It's too noisy, too hot, too chaotic for delicate quantum states to survive. But what if exotic matter or exotic fields permeate biological systems? What if microtubules can tap into zero-point energy or exotic matter fields that stabilize quantum coherence at body temperature? Suddenly, quantum theories of consciousness become much more plausible. This would mean your consciousness, your subjective experience of being you, isn't just the product of neurons firing in patterns. It's your brain interfacing with quantum fields that connect to the fundamental structure of spacetime itself. You're not just in the universe. You're of it, connected to it at the deepest possible level. This isn't mysticism. This is physics. And if it's true, it means that studying objects like 3I Atlas isn't just about understanding the cosmos out there. It's about understanding the cosmos in here, in your own awareness, in your own experience of being alive and conscious. Some researchers have even speculated that if consciousness is quantum and connected to space-time structure, then it might not be confined to biological brains. Dr. Gregory Matloff from the New York City College of Technology has proposed that panpsychism, the idea that consciousness is a fundamental feature of the universe, might be testable through observations of anomalous stellar motions that could indicate volition at cosmic scales. I know that sounds wild, but remember, a century ago, the idea of quantum entanglement particles remaining connected across vast distances sounded wild too. Einstein called it spooky action at a distance and thought it was so absurd that it proved quantum mechanics must be wrong. Turns out, quantum mechanics was right, and entanglement is real. The universe is spookier than Einstein imagined. What I'm saying is that we should be humble about declaring what's possible and what isn't. Reality has consistently proven to be stranger than our theories predict. And this brings me to perhaps the most important point I want to make in this entire video. Living through this moment of discovery should change how you see your place in the universe. You're not just a passive observer. You're part of the universe, becoming conscious of itself. Every time you learn something about how reality works, Every time you ask a question about the nature of existence, you're participating in the universe's quest to understand itself. Carl Sagan put it beautifully. We are a way for the cosmos to know itself. If exotic matter connects consciousness to quantum fields, if awareness is woven into the fabric of space-time, then this isn't just poetic language. It's literally true. Now, I want to address something that's probably been nagging at you this entire video. Could scientists be wrong about 3I Atlas? Could there be a mundane explanation for all these anomalies? The answer is absolutely. Science is always provisional. Every conclusion is subject to revision based on new evidence. Maybe the spectroscopic anomalies are caused by surface chemistry we haven't encountered before, but that involves only normal matter. Maybe the excessive brightness is due to unusual crystal structures that reflect light in unexpected ways. Maybe the coldness is an artifact of how we're measuring thermal emission from a rapidly tumbling object. These would be disappointing explanations if you're hoping for exotic matter and revolutionary physics, but they would still be interesting. They'd still teach us something new about planetary science and cosmic chemistry. But here's the thing. Even if 3I Atlas turns out to be less revolutionary than it currently appears, the questions it's forced us to ask remain important. The fact that we're now seriously considering exotic matter, alternative cosmological models, and radical possibilities for consciousness and reality, that's valuable regardless of what this particular object turns out to be. Science advances by proposing bold hypotheses and then testing them rigorously. Sometimes the bold hypothesis is confirmed, and we have a revolution. Sometimes it's refuted, and we learn something important about why reality doesn't work that way. Either outcome advances our understanding. But I want to be honest with you about where the evidence currently points. The anomalies surrounding 3I Atlas are not subtle. They're not marginal deviations that could easily be explained away by measurement error. Multiple independent teams using different instruments have confirmed observations that don't fit our current models. Dr. Michelle Bannister, who I mentioned at the beginning, gave an interview in October 2025 where she said something striking. In 30 years of studying comets and asteroids, I've never seen anything like this. And I've talked to colleagues who've been in the field twice as long as I have, and neither have they. Whatever 3I Atlas is, it's not something we have a ready explanation for. That's a careful scientist choosing her words precisely. She's not saying it's definitely exotic matter. She's not saying it's artificial. She's saying it doesn't fit the boxes we currently have. And when reality doesn't fit your boxes, you have two choices. Try to force it into a box where it doesn't quite fit, or build new boxes. The scientific community is choosing to build new boxes. New theories, new models, new ways of thinking about what's possible. And that process, that willingness to revise our understanding when confronted with anomalies, is what makes science so powerful. But there's a tension here that I need to acknowledge. The more revolutionary the claim, the more skeptical scientists need to be. Carl Sagan also said, extraordinary claims require extraordinary evidence. So while the anomalies surrounding 3I Atlas are real and confirmed, the interpretations exotic matter, dark fluid, quantum consciousness connections, those are still speculative. We need more data. We need more observations. We need theoretical physicists and observational astronomers working together to develop testable predictions. We need missions that can get closer to these interstellar objects, or at least observe them in more detail. This is the frustrating and exciting part of living through a potential paradigm shift. You don't get immediate answers. You get tantalizing hints, suggestive data, and the realization that something important is happening. But what exactly? That takes time to figure out. And this is where I want to talk about something crucial: the relationship between science and society during moments of uncertainty. Throughout history, whenever science has suggested that reality is fundamentally different from what people assumed, there's been resistance. Not just from religious authorities, though that's part of the story, but from within the scientific community itself. When continental drift was proposed by Alfred Wegener in 1912, most geologists rejected it. The idea that continents move across the surface of the Earth seemed absurd. The theory didn't gain wide acceptance until the 1960s when plate tectonics provided the mechanism. That's 5 decades of resistance to an idea that turned out to be correct. When Barbara McClintock discovered jumping genes' genetic elements that could move around in the genome. In the 1940s, her work was dismissed for decades. She finally won the Nobel Prize in 1983, but only after other scientists rediscovered what she'd found 40 years earlier. The point is that revolutionary ideas face resistance, even when the evidence supports them. This is actually healthy for science, because it means extraordinary claims get extraordinary scrutiny. But it also means that as a society, we need to be aware of this dynamic. Right now, the 3I Atlas observations are forcing a conversation about exotic matter and exotic physics. Some scientists are excited, some are skeptical, some are actively hostile to the idea. This is normal. This is how science works. But here's what I want you to take away from this. Regardless of which camp turns out to be right, the conversation itself is valuable. We're collectively grappling with deep questions about the nature of reality. We're taking data seriously and following it wherever it leads. We're building new instruments and planning new missions to gather better evidence. This is humanity at its best, curious, rigorous, open to revision, and committed to understanding truth rather than defending comfortable beliefs. And you're part of this process. Every person who learns about 3I Atlas, who understands the questions it raises, who follows the scientific debate as it unfolds, you're participating in this collective sense-making. You're helping create a culture that values discovery and is willing to update its worldview based on evidence. This matters more than you might think. The challenges humanity faces in the 21st century, climate change, artificial intelligence, biotechnology, resource scarcity, all require us to make decisions based on our best understanding of how reality works. If our models of reality are wrong, our solutions will be wrong. So getting the cosmology right, getting the physics right, understanding what matter actually is and how it behaves, this isn't abstract philosophy. This is the foundation for every practical application we'll ever build. If exotic matter exists and we figure out how to work with it, it could solve energy problems that currently seem intractable. If it doesn't exist, we need to know that too, so we can focus our efforts on solutions that do work with the actual physics of our universe. But beyond practical applications, there's something deeper at stake. There's a question about meaning and purpose that every human grapples with. Why are we here? What's the point of existence? For much of human history, people found meaning in religious narratives that placed them in a cosmic story. You were created by God for a purpose. Your life mattered in an eternal context. The universe was fundamentally about you, humanity, consciousness, moral choice. Then science came along and seemed to strip all that away. You're not created, you're evolved. You're not central to the cosmic story. You're a side effect. The universe isn't about you. It's indifferent to you. Physical laws govern everything, and those laws don't care about meaning or purpose. This transition from a human-centered universe to a mechanistic, indifferent one has been psychologically difficult for a lot of people. It's one reason why there's still cultural resistance to scientific findings. It's not just that people don't understand the science. It's that the implications seem to make life meaningless. But here's the thing. The universe that 3I Atlas is revealing isn't the cold, mechanistic universe of 19th century physics. It's weirder, richer, more full of possibilities. If consciousness is connected to quantum fields, if the vacuum of space is alive with zero-point energy, if exotic matter opens doors to exploration we can barely imagine, then we're not cosmic accidents existing briefly in an indifferent void. We're part of something vast and strange and wonderful. The universe is not only stranger than we imagine, it's stranger than we can imagine. And we conscious beings capable of understanding reality through mathematics and observation, we get to participate in that strangeness. That's not meaningless. That's extraordinary. Let me share something personal. When I first started researching 3I Atlas, I expected to make a video about an interesting comet with some unusual properties. The more I dug into the scientific literature, the more I talked to researchers, the more I realized this is so much bigger than that. This object has become a focal point for questions that physics has been dancing around for decades. Questions about the nature of space and time, about whether there are forms of matter we've never encountered, about whether the cosmos is far more alive and active than we thought. And what strikes me most is the timing. We're living through a moment when multiple lines of evidence are converging. The detection of gravitational waves opened a new way of observing the universe. The James Webb Space Telescope is showing us the early universe in unprecedented detail. Quantum computing is revealing how strange quantum mechanics really is. And now, interstellar objects are bringing samples of exotic physics literally to our doorstep. It feels like the universe is trying to tell us something. I know that's anthropomorphizing the universe doesn't have intentions, but there's a pattern here. We've developed the technology to ask certain questions, and immediately the universe provides opportunities to answer them. Oumuamua showed us that interstellar objects pass through our solar system. Borisov showed us that we can study their chemistry. And now 3I Atlas is showing us that some of these objects have properties that challenge our entire understanding of matter and energy. What comes next? If the pattern holds, we'll detect more interstellar objects with even stranger properties. We'll launch missions to study them. We'll develop new theories to explain them. And step by step, mystery by mystery, we'll figure out what's actually going on. But here's what I want you to understand, your sixth mind-blown moment of this video. We're not just passive recipients of this knowledge. We're active participants in creating it. The scientists studying 3I Atlas? Many of them are in their 30s and 40s. Some of them grew up watching science videos on YouTube, reading popular science books, getting excited about space because someone took the time to explain it to them. The engineers designing the next generation of telescopes and spacecraft? Some of them are in high school right now, watching videos like this, wondering if they could contribute to humanity's understanding of the cosmos. The investors and policymakers who will fund the missions that investigate these objects? They're influenced by public interest and excitement. When people care about space exploration, resources flow toward it. So when you watch this video, when you share it with friends, when you have conversations about what 3I Atlas might mean, you're not just consuming content. You're participating in a cultural shift. You're helping create a world where these questions matter, where resources get devoted to answering them, where the next generation grows up thinking that understanding the universe is important and exciting. That might sound grandiose, but it's true. Culture shapes what we value. What we value shapes where we direct our collective attention and resources. And where we direct our attention and resources determines what we discover and what we accomplish. Carl Sagan understood this. That's why he wrote books and made TV shows. That's why he worked so hard to communicate science to the public. He knew that the future of space exploration didn't just depend on scientists and engineers. It depended on everyone understanding why this matters and caring enough to support it. And here we are, decades later, living through exactly the kind of moment Sagan dreamed about. We have evidence of something extraordinary passing through our solar system. We have the technology to study it. We have a global community connected by the internet who can all participate in the excitement and wonder of discovery. This is what he hoped for. This is the world he tried to help create, and you're part of it. So let's talk about what happens next. Where does the 3I Atlas story go from here? In the immediate term, the next few months, astronomers will continue gathering as much data as possible before the object gets too faint to observe. Every spectroscopic measurement, every thermal image, Every photometric data point adds to our understanding. There are specific observations that could resolve some of the uncertainty. If 3I Atlas shows any signs of outgassing releasing volatile material as it warms, that would tell us something about its composition and might explain some of the anomalies. If it doesn't outgas at all, that's also informative because it would suggest the object is structurally very different from normal comets. Researchers are also analyzing the object's rotation and tumbling pattern. The way it spins can tell us about its shape and internal structure. If it's a solid piece of exotic matter, it should tumble differently than if it's a rubble pile of normal material held together by gravity. In the medium term, the next few years, we'll see a flood of scientific papers analyzing the data. Theorists will propose models to explain the observations. Some models will make predictions that can be tested. Other interstellar objects will be detected, and we'll see if they show similar properties. This is where the scientific process really shines. Individual observations can be ambiguous, but patterns across multiple observations become much harder to explain away. If every interstellar object we detect is weird in different ways, that suggests our models of how these objects form need revision. If most are normal, but a few are weird, that's also informative. It suggests there are rare, but natural processes that produce exotic objects. In the longer term, the next decade or two, I predict, we'll see dedicated missions to intercept and study interstellar objects. Not 3I Atlas specifically, it's already too far away, but future objects detected earlier in their approach to our solar system. The technology for rapid response missions is being developed right now. Small, lightweight probes that can be launched quickly on powerful rockets. Sail-based propulsion that uses the sun's radiation pressure to accelerate to high speeds without needing massive amounts of fuel. These missions could potentially reach interstellar objects while they're still close enough to study in detail. Imagine a probe that actually lands on an interstellar object that collects physical samples. That can do close-up spectroscopy and determine exactly what these things are made of. That's not science fiction. That's achievable with technology that exists or is in development right now. But here's what really excites me about the long-term implications. Studying 3I Atlas and similar objects forces us to develop the technology and knowledge base we'll need to become an interstellar species. If we can figure out how to rapidly launch missions to intercept fast-moving interstellar objects, we've developed the technology for interstellar travel. If we can understand exotic matter and how to work with it, we've potentially solved the propulsion problem that currently makes interstellar travel seem impossible. In other words, these objects aren't just puzzles to solve for intellectual satisfaction. They're the universe providing us with a curriculum for how to become a spacefaring civilization. First, we learn to detect interstellar objects check. We're doing that now. Second, we learn to study them from a distance. We're in this phase. Third, we learn to send missions to them. That's next. Fourth, we learn to extract resources from them and potentially use them as way stations for longer journeys. Fifth, we learn to build our own interstellar vessels using the principles we've discovered. It's a progression. Each step builds on the last. And 3I Atlas is teaching us what we need to learn for step 2 and step 3. This is how civilizations advance. Not through abstract theorizing in isolation, but through engagement with the universe. Through curiosity about what's actually out there. Through willingness to be surprised and to update our models when reality shows us something new. Now, I want to address something that might seem like a tangent, but connects to everything we've discussed. The question of time, scales, and cosmic perspective. One of the most disorienting things about astronomy is that the time scales involved are so vast that they're hard to comprehend. Stars take millions of years to form. Galaxies collide over billions of years. The universe is 13.8 billion years old. From that perspective, human civilization is barely a blip. We've had writing for maybe 5,000 years. We've had science for maybe 400 years. We've had the ability to detect interstellar objects for less than a decade. This can make everything seem futile. Why does any of this matter when the sun will eventually die, when galaxies will drift apart as the universe expands, when the ultimate fate of everything seems to be heat death, a cold, dark universe where nothing interesting can happen anymore? But here's what I want you to consider. That distant future trillions of years from now isn't now. Now is when interesting things are happening. Now is when stars are forming and planets are evolving and civilizations are discovering the laws of physics. And if exotic matter exists, if there are ways to tap into zero-point energy, if the universe is richer and stranger than we thought, then maybe that far future isn't as bleak as it seems. Maybe advanced civilizations will find ways to persist through cosmic changes we can't imagine. Maybe consciousness and life are more fundamental and more resilient than we think. But even if none of that is true, even if the universe really does end in heat death, so what? That's trillions of years from now. Right now, in this moment, you're a conscious being capable of understanding that you live in a universe billions of light years across, governed by quantum fields and relativistic space-time, full of exotic phenomena we're only beginning to detect. That's extraordinary. That's meaningful. Not because it lasts forever, but because it's true right now. The universe has given rise to structures complex enough to contemplate themselves. In you, the cosmos has become self-aware. For this brief flicker of time, your lifetime, you get to experience existence, to ask questions, to seek understanding. 3I Atlas is a reminder of that privilege. This object traveled for possibly millions of years through the void between stars, carrying matter in exotic states, and arrived at our solar system at precisely the moment when we've developed the technology to detect and study it. You could see that as coincidence, or you could see it as you being alive at exactly the right moment to witness something profound. Let me bring this full circle by returning to where we started. The claim that 3I Atlas brought something we're not ready for. What has it brought? Not just exotic matter or strange spectroscopic signatures. It's brought questions that challenge our entire framework for understanding reality. Are we ready for a universe where negative mass matter exists? Where the vacuum of space isn't empty, but full of energy we could potentially harness? Where consciousness might be quantum and connected to the fabric of space-time itself? Where interstellar travel might be possible within a human lifetime? Honestly? No, we're not ready. Our physics is still incomplete. Our technology is still primitive. Our civilization is still struggling with problems that unlimited clean energy could solve. But here's the beautiful thing about humanity. We rise to challenges. We might not be ready, but we adapt. We learn. We build new tools and develop new theories. We expand our understanding to accommodate new realities. A century ago, we weren't ready for quantum mechanics. It violated our intuitions about how reality works. It required entirely new mathematical frameworks. It suggested that observation influences outcomes and that particles can exist in superposition states. That all seemed crazy. But we adapted. We built quantum mechanics into a rigorous theory. We developed technologies based on it: transistors, lasers, MRI machines, quantum computers. We expanded our conception of reality to include quantum phenomena, and we're richer for it. The same thing will happen with whatever 3I Atlas is teaching us. We might not be ready now, but we will be. We'll develop the mathematics to describe exotic matter. We'll build instruments to detect it reliably. We'll figure out how to work with it. And in a few decades, phenomena that seem impossible today will be the foundation for technologies that transform civilization. That's what humans do. We encounter the unknown. We study it. We understand it. And we integrate it into our worldview. We're not passive recipients of knowledge. We're active creators of understanding. And all of this, from the detection of 3I Atlas to the theories being proposed to explain it, to the missions being planned to study future interstellar objects. This is humanity at our best. We're curious. We're cooperative. Scientists from dozens of countries are sharing data and working together. We're ambitious. We're already talking about missions that would have seemed like fantasy a few years ago. We're humble. We're willing to admit that we don't understand everything and that we need to revise our models. This is what it means to be a species that's waking up to its place in the cosmos. For millennia, we were confined to one planet, looking up at lights in the sky and telling stories about them. Now, we're studying those lights in detail. We're detecting objects from other star systems. We're planning to visit other planets and eventually other stars. 3i Atlas is part of that journey. It's a signpost telling us that the universe is richer than we imagined, that there's more to discover, that the adventure is just beginning. So where does that leave you? What are you supposed to do with all this information? First, maintain a sense of wonder. It's easy to become jaded in the information age. You're bombarded with content constantly. Everything becomes just another thing to scroll past. But don't let that happen with this. Let yourself be amazed that we live in a time when we can detect objects from beyond our solar system. Let yourself feel the strangeness of a universe that might contain exotic matter and zero-point energy and phenomena we haven't even imagined yet. Wonder is the engine of curiosity, and curiosity drives discovery. If you can maintain that sense of wonder, you'll stay engaged with these questions as they unfold. Second, stay informed. Follow the science as it develops. Read the papers when they're published. Watch for updates as more data comes in. Don't just accept the first explanation you hear. Engage with the debate. Understand the different perspectives. Think critically about what the evidence actually shows versus what people are speculating. This is your education in how science actually works, not as a collection of facts in a textbook, but as a living, ongoing process of discovery and debate. Third, share what you've learned. Talk to friends and family about 3i Atlas. Explain why it's significant. Help other people understand what's at stake. The more people who care about these questions, the more likely we are as a civilization to devote resources to answering them. You have the power to influence culture. Every conversation you have, every time you express excitement about space exploration and fundamental physics, you're making it more likely that we live in a world that values these pursuits. Fourth, consider how you might contribute directly. If you're young enough that you're still choosing a career path, consider science or engineering. The researchers studying 3i Atlas right now aren't superhuman geniuses. They're people who got interested in astronomy, who studied hard, who built careers in a field they found fascinating. That could be you. The next generation of telescopes and spacecraft will be designed by people who aren't famous yet, some of whom are watching videos like this right now and thinking, that sounds amazing. I want to be part of that. But even if you don't pursue a career in science, there are ways to contribute. Support science education and outreach. Vote for politicians who fund space exploration and basic research. Donate to organizations doing this work if you can. Teach kids to ask questions about the universe. Every contribution matters because science and exploration are collective endeavors. They require societies that value truth-seeking and support the patient work of understanding reality. And finally, and this might be the most important thing, let this change how you see yourself. You are not separate from the universe. You are made of atoms forged in the hearts of stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar furnaces billions of years ago. You are the universe experiencing itself. When you look at a sunset or contemplate a mathematical equation or feel a surge of emotion, that's the cosmos engaging in self-reflection through the specific pattern of matter and energy that makes you. 3i Atlas passing through our solar system, carrying exotic matter from the space between stars, is one part of the universe encountering another part. And you Learning about it and thinking about what it means are a third part becoming aware of both. It's all connected. It's all one vast, interconnected web of matter, energy, space, and time, unfolding according to mathematical laws we're slowly figuring out. That's not a cold, mechanistic picture. That's beautiful. That's sacred in the most profound sense, not because any deity decreed it, but because existence itself is extraordinary and worthy of reverence. When you understand that, when you really feel it, it changes everything. Suddenly, your life isn't just about paying bills and fulfilling obligations. It's about being a conscious node in a vast cosmic network, capable of understanding and appreciating the whole. That's what 3i Atlas is ultimately about. Not just exotic matter or revolutionary physics, but a reminder that we live in a universe far stranger and more wonderful than we typically remember in our day-to-day lives. As we come to the end of this journey together, I want to leave you with one final thought. The universe has been around for 13.8 billion years. Modern humans have existed for 300,000 years. You personally will probably live for 70 to 100 years if you're fortunate. That's a tiny, tiny slice of cosmic time, but it's your slice. This is your moment to be alive, to be conscious, to witness and participate in the grand story of existence. And you happen to be alive at precisely the moment when humanity is transitioning from a planet-bound species to a spacefaring civilization, when we're detecting interstellar objects and planning missions to study them, when we're grappling with evidence that might overturn our understanding of physics, when we're seriously discussing technologies that seemed like pure fantasy just decades ago. You didn't choose to be born at this moment, but here you are, and you get to decide what to do with that extraordinary coincidence. You can ignore it, treat it as just another piece of information to file away and forget. Or you can recognize it for what it is, an invitation to participate in something larger than yourself, to engage with the deepest questions humans have ever asked, to contribute in whatever way you can to our collective understanding of reality. The choice is yours, but I hope you'll choose engagement. I hope you'll stay curious. I hope you'll maintain that sense of wonder. I hope you'll share what you've learned and inspire others to care about these questions. Because this is how civilizations grow, not through individual geniuses working in isolation, but through communities of curious people supporting each other, sharing knowledge, building on each other's insights, and collectively pushing the boundaries of what's possible. 3i Atlas came from beyond our solar system, carrying something we're not ready for, evidence that challenges our physics, possibilities we haven't imagined, questions we're only beginning to ask. But we will be ready. We'll rise to this challenge just as we've risen to every challenge in our history. We'll figure it out. We'll expand our understanding. We'll build new technologies. We'll explore deeper and reach farther. And decades from now, when the exotic matter theories have been confirmed or refuted, when the missions have been flown, when the textbooks have been rewritten, someone will make a video about how humanity navigated this moment of uncertainty and discovery. And you'll be able to say, I was there. I watched this unfold. I was part of the generation that first grappled with evidence of exotic matter. I helped create the cultural context that made the next discoveries possible. That's your legacy. That's what being alive right now means. So thank you for being here. Thank you for caring enough to watch this entire deep dive. Thank you for being curious, for asking questions, for seeking understanding. The universe is vast and strange and beautiful, and you're part of it. Never forget that. If this video blew your mind, and I hope it did at least 6 times, make sure you hit that like button and subscribe to the channel. Drop a comment letting me know what you found most fascinating. Were you more intrigued by the exotic matter possibilities, the implications for consciousness, or the practical applications, like faster-than-light travel? Also, share this video with someone who needs a sense of wonder in their life right now. We could all use a reminder that we live in an extraordinary universe full of mysteries waiting to be solved. Until next time, keep looking up, keep asking questions, keep being amazed by existence.